If not, I'll just delete it. But here we go.
Okay.
All right, so you got something on there, looks like. We'll click on that bad boy. All right, I clicked on them. Waiting for it to show up. Okay, so I think it's getting ready to come up. It's being slow, I guess. All right, so now let me see if I can zoom in on that because I can barely see it. It says exit to full screen. Let me see. See if I can. Okay. Okay, I just clicked on it. Maybe it'll. Okay, let me see. All right, so I can't. I'm pretty sure you can probably see it on a screen. If I were on YouTube, I could probably zoom that in. Let me see if I can. Okay, there you go. Oh, now that's a lot better. Okay, cool. All right, we can do that. So when you get to do is see, when they're set up like these polynomials, and so to do that you have to factor. So you see the top. Let's say you're doing letter A. Okay, you're doing letter A, and it is it's x squared minus x minus 12 all over 2x plus 6. Well, the easier one to factor is on the bottom. And you can see that it's saying as x approaches -3. Well, if you put -3 in that denominator, you're going to get 0. And that's kind of almost the whole point of dividing by a number that's infinitely close to 0, but not really 0, because dividing by 0 is not possible. You can't do it. It's called indeterminate. So you can't have the word division means divide equally. You can't divide things equally into 0 parts. So what you have to do is say, okay, well, since we know we can't do that, now we have to do something called removable discontinuity. Now let me show you what's a little bit misleading. So I'm gonna come off of here and I'm gonna share a screen myself. I'm gonna go on here. I'm gonna go on here to Desmos. I'm gonna have you this. Hopefully our connection's good because mine's acting a little slow, probably because we have a lot of stuff streaming right now. She's up there streaming a Zoom herself. Okay, so now I'm going to go to Desmos and I'm going to put this actual equation in. I'm going to show you how this is one of the reasons why you need to do this removable discontinuity is because you'll be misled. If you go to graph this, you'll be certainly misled. So that's what I'm going to pull this up. Okay. How's your internet doing?
I'm doing pretty good right now.
Okay, so I might end up if I can't get this thing to move faster, I might just have you pull the same thing I'm trying to pull up, but I'll see if it starts speeding up a little bit. I'm at in the basement in the other end of the house, so the signal's not as strong down. Really? Let's see here. Okay, so I'm going to give it about 2 seconds. If it doesn't pull up. Okay, here we go. All right, so now what I'm going to do is I'm going to put the top equation in parentheses, and you're going to see it here shortly as soon as I get done typing it all in. Let's see. Minus x minus 12. Come on, there you go. And then divided by 2x plus 6. Okay, so this is, you're going to see this as soon as it gets done here. Okay, so now what I'm going to do, I'm going to go back to StreamYard. I'm going to click on present. Let's see how that does. Let me go to that. All right, so, okay, Desmos, yep. All right, let's see if this pulls up. Okay, now let's see. Did that pull up for you? Let me look. Okay, yeah, it's getting ready. It's getting ready to pull up. It's going to override what you had up there. So what do you notice here? What does that look like?
Infinite.
See the red? I think it's red. See the red line?
Yeah.
So it looks like a line, right? It's kind of misleading though,
Right.
because if you go to this line, let me see if it'll allow me to do this. What does it saying the limit is as x approaches what?
It says x approaches -2.
See where it says x approaches? That's right. So if I were to go, can you see where this mouse is going right now?
Mm-hmm.
You see that?
Yeah.
Can you see the mouse where I'm moving it?
Yeah.
The arrow? See the arrow? Okay, now I'm at -3. And notice that this I don't know if you can see what the y value is there, but it's basically, what is that? Each one of those every two of those blocks is worth 1, so that's 3.5. So what it looks like, -3.5. So I'm going to write that down, -3.5. So what's misleading about that is if I were to click on that actual location, and I'm looking at -3. So if I were to click on this location, shoot, let me go back to it. I guess let me go back to it. If I were to click on it, if I were to trace it, which is not letting me, here we go. So I want to go to -3. If I go on it, watch what happens when I get to -3, right? Getting there. X is -3. Okay, here we go. Right there. Look at it. See what that is?
Mm-hmm.
What word came up?
Undefined.
You see the word that came up?
Yeah.
Exactly. That's the hole in the graph. Okay, and that hole is called removable discontinuity. Now the limit is right at that location because from both directions it's hitting the same height, but that's where calculus comes in a little bit. So what we do is, if we were doing this just algebraically without factoring, we would have to put really close numbers that are infinitely close to -3, like -2.9. But with removable discontinuity, we can get a little bit more exact. Okay, so now we'll go back to your problem. Let me click on that again. See if it'll let me do that. All right. Okay, so let me unpresent. Let's see if it'll let me unpresent. All right, here we go. So I'm going to click. Let's see if it goes back to yours again. Okay. All right, let's go back to yours. Just give me a second here. Okay, let's see what's going on. I don't see it go there. Okay, add the stage. I said add. All right, so it should pull it back on there. Let me see. Okay, well, okay, let's try it again. So there we go, right there. Okay, there it is. It's popping up now. I think it is. There it goes. Okay, can you zoom in on that again?
Yeah.
Okay, so now after you're done zooming in, so now we're going to go back to the problem and we're going to prove that this has some removable discontinuity. So what we're going to do is we're going to say, okay, what factors, what's the biggest number that divides into 2x plus 6?
Mm-hmm.
What's the biggest number that divides into 2x and that divides into 6?
3.
Well, 6 divided by 2 is 3, but what about 2 divided by 2?
Oh.
So in other words, 2x plus 6, if I divided both of those numbers on the bottom by 2, I divide both by 2, what do I get? I get 2 times, in parentheses, x plus 3.
Oh,
You follow that?
oh,
So, all right.
okay.
Would you agree that 2 times x is 2x? And you'd agree 2 times 3 is 6, right?
Yeah.
Okay, so then 2 times the quantity, x plus 3, is the same thing as 2x plus 6, right? So now what we
Yeah.
have on the bottom is 2 times x plus 3. And then on the top, the assumption is that if something's going to be removable, it's got to have x plus 3 in it. So if it doesn't have x plus 3, then it's not removable discontinuity. And if that's the case, then there would be no limit. There would be, you would not be able to find the limit. At least you wouldn't be able to find an exact limit. Okay, so now what we're going to do is on the top, we're going to make the assumption that x plus 3 is up there. We're going to say, okay, does x plus 3 go into x squared minus x plus or minus 12? So here's what you have to ask yourself. What two numbers multiply together to give you negative 12 that add together to give you negative 1? Since you see that, so you have negative 12 on the top and you have negative 1 in the middle, right?
Yeah.
So what two numbers
Negative,
multiply together to give you negative 12?
-4 and +3.
Yeah, exactly. There you go. And since we already know the other one is x plus 3, guess what the other one has to be?
X plus 3.
You already told me on the top. We already know that x plus 3 is going to be there. We assume that because it's on the bottom. So then what's the
Yeah.
other one going to be? You just told me what two numbers multiply together to give me 12. And that adds
Oh,
together to
X
give you
minus
negative 1.
4.
And the answer was 3 and what? That's right. So the other number is
X.
x minus 4. You understand that?
Mm-hmm.
So what's on the top now?
X
What's
minus
on
4
the top?
times X plus 3.
There you go. What's on the bottom?
2 times X plus 3.
Okay. So what's the same on the top and the bottom?
X plus 3.
Exactly. That's funny. Your text just came through. Okay, so right. So if x plus 3 is on the top and x plus 3 is on the bottom, you just cancel both of them. Cross them out, and then what's left?
X minus 4 over 2.
Exactly. Exactly. But now what we have done is removed our problem. See, our problem is we can't divide by 0. But we have eliminated that problem because now we don't have anything on that bottom except 2. So now we're no longer dividing by 0. We can go ahead and substitute in the limit. I mean, as x approaches negative 3, we can substitute x equals negative 3 into the equation and get the limit. So what's negative 3? So you substitute negative 3 in there, right?
Mm-hmm.
So what are you going to be? You're going to get negative 3 minus what?
4.
Yep, all over?
2.
All over 2. Yep, so what's negative 3 minus 4 more?
Negative 7.
That's correct. And what's negative 7 divided by 2? You remember what we said it was on Desmos?
Oh. No. 3.5?
Yeah, that's right. It was negative 3.5, and that's the same answer we just got. Negative 7 over 2 is the same thing as negative 3.5. Okay. All right, go ahead and zoom in on those problems. We'll see which other ones are maybe like that or different and so on, and we'll see and maybe have you try one or two of those bad boys. Okay, so very okay. And then let's go ahead and have you. Let's try to do letter B. See what happens. So now let me look at the directions real quick. What does this say? It says, does it say determine the limits analytically?
Yeah.
And then it says show your work. Well, analytically could be from graphing, be from anything. Is that all it says on the directions?
Yeah.
Okay. Okay, so what we have to do, again, we go to the bottom. See letter B? So what do you have to ask yourself if you're going to factor that? What two numbers do what?
Multiplies to get to 4 and add to get to -4.
To give you? Okay, well, that's correct. And that would be what?
Negative.
You only have two options. 4. Yep, go ahead.
-2.
Right. So it's going to be t minus 2, t minus 2 on the bottom. What are we going to assume is on the top?
T minus 2.
That's right. Right. So then the next question you're going to ask yourself is the same as you did on the bottom. What two numbers do what?
Add to get to 1 and multiply to get to -6.
That's right. What would that be? Since you already know one of them is what?
-2 and 3.
Right. What's make? Yep. There you go. So what are we going to cancel?
-2.
Yeah. And so this one's going to be quite interesting because this is very interesting. Okay. So this one here, you're going to cancel out t minus 2 and t minus 2. But then you're still going to be left. And what does this say? Limit as x approaches what?
2.
I mean, as t approaches 2? Is that what it says?
Yeah.
Yeah. So this one's not going to work out that well, but we'll go ahead and go through. We just cancel out on top and the bottom. We have a t minus 2 and a t minus 2. So we can only cancel out 1 for 1. But then when you go to put what you still have t minus 2 times t, you still have a t minus 2 on that denominator. All right. So problem is I go to substitute that 2, I still get 0. That tells me is I was not able to take the graph and get rid of the discontinuity. So if I go to graph this, I'm going to show you what it does. So let's go. It was what was the original? You can't use t's on Desmos. You have to use x, but it was not what it was. Plus x.
Mm-hmm.
And then what was the other part of that? Plus or minus 6.
Yes.
And then all over, we're going to call it x. Let's see, x. No, wait a minute. X squared. And then what was the rest of that? It was, let me see. Okay. So it was x squared minus 4.
T.
What was on the bottom, David?
Plus.
Oh. I mean, it was t, but I mean, we have to use x's. So it was what? T squared minus what?
4t plus 4.
Minus 4t plus 4.
Yes.
Okay. All right. So you're getting ready to see something here. Okay. So this one here is a little, it's going to be a lot different. So I'm going to go ahead and present this one. Let's see. All right. I'm going to stop. that one. I'm going to stop that one. Hold on a second here. And then I'm going to present. Okay. Okay, I need to present this other. Hold on a second. Hello?
EJ,
Yeah.
what's your comfort level with plumbing? Well, just for
Okay. When's he going to do that?
so the cabinets will be delivered on Friday, so not Friday and Saturday. So maybe by Saturday is my guess.
Okay. Well, let me know. Yeah, I don't have any problem doing that as long as I'm not already have a schedule conflict.
Well, I'm trying to get it his neighbor because his neighbor talks a good game.
Yeah, he's a professional.
I know, but when it comes down to doing stuff, I don't know if he actually does. Because Dad had to pay for some plumber to come out and do some other work.
Well, he's getting old and he's had some issues. Huh? Oh, you must be talking about a different guy. I was talking about Bob next door.
Oh, no, Tim.
Okay.
The other guy.
Okay. Yeah, I'm not sure about that. Yeah, I'm not sure about that.
Also, I did text little EJ because I knew JoJo was going to be gone. If we could use some hands, this would help. Like holding the cabinets while Art puts them up.
Okay. Well, yeah, you already at least. Yeah. Did he ever agree to doing the Betty thing?
I have her back though, I guess.
Okay. Okay. Well, I'm not sure, but all right. Well, just give me a little reminder.
Yeah, I'll let you know for sure. I'll see Tim hopefully tomorrow. I feel like there's something else I was going to tell you. Someone really needs to talk. Like, that may not be the dude is just that he blacked out medical stuff. He's got his issues with that zero circulation.
Yeah.
Pretty sure he doesn't know.
Right. Yeah, he doesn't listen either, but right. Yeah, well, at least try to talk to him. I don't know if it'll do any good, but yeah. Yeah, he just goes drinks. All right. Well, let me know about Saturday. I'll yeah, I think this Saturday I can help. Next Saturday I wouldn't be able to, but yeah, I think this Saturday. Oh, yeah. Let me know about it because we have our cookout thing too. But yeah, just
I'll let you know when that's tomorrow. And then the last thing is eventually we're gonna do this dumpster while we still agree to it.
okay.
I think we just started the house. I don't know where his storage is and what the rules are.
Okay, good deal.
All right.
Bye. All right. Anyway, so now, do you see the difference in that graph as compared to the last one?
Mm-hmm.
Yeah. So if you notice, it has some. Well, let me say it another way. When X is approach, or excuse me, in this case, we're going to call it. It's supposed to be T, but when X is approaching 2 from the left side, you see what happens? The graph is heading. See, remember when you graph, you go left to right, just like kind of like reading, right? So you go from left to right. You go left to right. when you're heading towards 2, you end up going down to negative infinity. But if you're going from the right side of 2, right? If you go from the right side of 2, then you're heading towards positive infinity. You see that?
Yeah.
They should have made you get a graphing calculator too. And so if you put this in the calculator, do you have a graphing calculator?
No, right now.
Okay, you need to get one. But if you put this in the calculator and if you were to type in instead of 2, type in 2.0001, and if you were to have this graphed in the calculator, you could put it. You could make 2.001 your x value and trace where it went, or you could put it in. You could store it and make the calculator go through the calculation, and what you would find is it would be an astronomically large number, which means from the right side it's going up to infinity. And if you were to put 1.9999999, it would be an astronomically low number because it's going to negative infinity. So what happened was when we went to factor this, it still had that negative 2 down there, and you can't divide by a negative. So when you can't divide, you can't divide by 0. So when you can't divide by 0 and the limit makes you divide by 0, that means it's going to do something similar to what you see on this graph, which is it's not really going to have a limit, because a limit, in order to have a limit, you have to, if I say x is approaching 2, that implies that from both directions it's landing on the same place. But since it's not, it's where when you get a little deeper into this, you're going to be, instead of them saying approaching 2, they're going to say approaching 2 from the right. So they'll put a little plus symbol on top of that 2. Then from the right, you would say what? You would say as t approaches 2 from the right, what's the limit? You would say infinity. And then you would say as t approaches t from the left, if it had a 2 with a little minus sign on top of the 2, that would mean from the left, and you would be saying put negative infinity would be the limit. You follow that?
Mm-hmm.
Which is kind of weird too, because infinity is not really a limit. You can't limit infinity. Infinity goes on forever, but it's what it really means is that it goes on forever. Okay, so that's that. So now if you want to, let me take that off and see if I can take that off. Let me see how that works. Let's see, stop screen. I'm going to stop that one. And then let's go ahead and pull that back up. So what would we see if it pulls up? So that last problem, it says, what does it say in the directions? Because I can't read the directions. Okay, so evaluate each of the following limits. Okay, so anyway, so the answer is so letter B, D and E is what you would say the answer is. Does not exist. Okay. Now, like I said, if they redefined it and they said 2 from the right, then you would say positive infinity, and 2 from the left, you'd say negative infinity.
Mm-hmm.
Okay.
Yeah.
Okay, now. Okay, so let's see if we can find one that's challenging. Let's go to, let's scroll that over. Okay. All righty. Okay, so what I'm going to have to do is, okay, so yeah, these are getting interesting, much more interesting. So let's take a look at, so letter D, that's one you should be able to do based on what we've already done. Because what's going to be the denominator? And we're going to get back to this. Let's scroll over a little bit to the left. I want to go ahead and entertain. I'd like to entertain letter C, letter E, letter F, and then we'll call it a. How many are there, by the way? How many letters are there?
It just keeps going.
These are pretty challenging. Okay. Yeah, buddy. All right. So let's do. Go over to letter. Let's take a look at letter D and just talk about that real quick, and then we'll move from that to one of these other ones. Okay. So on the bottom, if you're just looking at that, what two numbers? What are you going to ask yourself? It's going to be what two numbers do what?
Add and subtract to get -4. I mean, add to get to -4, and then multiply to get to 4.
Exactly. And what's that going to be?
-2 and 2. -2.
Yep. -2, right. So the assumption is that -2 is probably on the top. So then same question, what's that going to be?
T plus 3 times T minus 2.
Okay. And so what's going to cancel again?
T minus 2.
And this one also says as T approaches 2.
Yeah.
Okay, so what do you think is going to happen to this one once again? Because you're still going to have a T minus 2 on the bottom.
Vertical asymptote.
Well, it's going to have so when you say what's the limit going to be, what's it going to be?
Does not exist. D&E.
Yeah, it's going to be another D&E. I don't know what they're telling you guys to put. Every college might have a preference, but it's D&E. It might say no limit, something like that. Okay, let us go to letter E, I believe it was, and then we'll. It's letter C. Let's go to letter C. So letter C. And then let me tell these people. Let's see. Okay. All right. Need help with Dad's Kitchen Saturday. All right. So now that's that. Okay. So now you got 9 minus y on the top. So this is a totally different technique that we haven't done yet. So again, if you put 9 in there, square root of 9 is 3. And so 3 minus 3 is 0. You can't divide by 0. But this technique is 100% different than what we just got done doing, except for the fact that we're still trying to get some removable discontinuity. But how you handle this one is called conjugates. So what you do is you say, all right, what's the conjugate of 3 minus square root of y? Do you recall what that is? So a conjugate says exactly the same thing, except if one's minus, the other one is positive. And what it does is conjugates can get rid of messy stuff on denominators. Like it can get rid of, like when you can't not really supposed to take the square root of a negative or square root. You're not supposed to keep square roots in denominators. So conjugates are a way to get rid of those square roots and things like that. So what's the conjugate of 3 minus square root of y? It's going to be 3 plus the square root of y. But the way math goes is whatever you do to the bottom, you do to the top. So you multiply the top and the bottom by, and see what you want to do at the top, you want to put that in parentheses. But once you multiply that denominator by its conjugate, you don't have to multiply it all out because the middle part's going to cancel anyway. So so 3 times 3 is 9. And then square root of y times the square root of y is y. And a negative times a positive is a negative. So what are you going to end up on the bottom with? Remember, the middle is going to cancel. Don't have to multiply. Just 3 times 3, and then which is 9. And then square root of y times the square root of y. See, way you handle square roots, it's just like saying y to the 1/2. And the way you deal with exponents is you add them. So y to the 1/2 times y to the 1/2 is y to the 1, which is the same thing as just y. And positive y times negative y is negative y. So the new denominator is 9 minus y. Did that make any sense?
Yeah.
Okay. Now I could go ahead and FOIL that top, but it's unnecessary because remember, all I have to do, the goal is to make sure you can't, is to eliminate the need to divide by 0. Or the you're trying to force this or manipulate it so you don't divide by 0. Okay, and if you can do that, you're doing what's called removable discontinuity. And then what that effectively does is instead of having asymptotes, you have holes in the graph. So it becomes a part of a graph that discontinues. It's called discontinuous, but it still allows it to continue being a function. Because see, a function has to be, not violate the rule that is for every one input, there's at most one output. Okay, you can have holes in the graph and still be a function. It's just called a discontinuous function, but it's still a function. So, anyways, the bottom is 9 minus y. Now, what did they say the limit as y approaches 9? Oh, actually, that doesn't help me very much. Oh, actually, it does. I was getting ready to say 9 minus 9 is still 0. At first I was going to say that's not going to help us, but then I just noticed something. What do you see on the top?
The same thing was on the bottom.
Exactly. So now they cancel. When they cancel, what's the new number on the bottom?
1.
That's right. It's 1. So now we go ahead and cancel everything on the bottom. We have 1 on the bottom. We have 3 plus square root of y all over 1. What are we going to substitute?
The 9.
Exactly. What's the square root of 9?
3.
Exactly. And 3 plus 3?
That's 6.
There you go. There's your answer. Limit is 6. Again, if we were to put that into that Desmos, you would have a hole in the graph. You would have a hole in the graph at x, or at in this case y, at y equals 9. You would have a hole there actually in the graph for Desmos. You would have to make Anyways, the x, you would make the x actually. I mean, the y would become x on Desmos. So you would have a hole at that 9, but it would be a function still. It would be like a straight line, something like that. Or just a number. Might be just a number. We'd have to put that on there. Let's take a look at what that does. And let's take a look here. 9 minus y. Let's see. 9 minus y. Let's see. 9. I'm going to put in parentheses. 9 minus x divided by, what was on the bottom there?
3 minus square root y.
Okay. Okay, so now I'm going to get rid of this other stuff. Okay, and it's not a line. It's actually it's actually the graph of what's it's like the graph of a square root, which kind of makes sense because you're taking anyway, so it's an exponential graph. So it's, I can show it to you here. Let's see. It looks like this. Let me do the present here. Share screen. Okay, here we go. So here's what it looks like. And if you look here, once again, it's kind of hard to see this, but see if I can move this graph around. I don't just look right here. Now, what did we say the limit was? You remember?
6.
Yeah. Now look at this. See, I don't know if you can see the numbers I'm on 8 point when I'm at 8.94, which is pretty close to being 9, right?
Hmm.
This graph is at 5.99. If I move, bam, I can't get it to stay there, but what do you read?
Undefined.
Exactly. That's the hole in the graph. So what we did is we allowed this to be a function by manipulating it a little bit. And so that's kind of the gist of that. Let me stop that. Get back to your stop that here. Okay, pull that back up there. It'll go up here eventually. Okay, it's coming up. All right, now, so that's that one. That's letter C. And let's see here. Yeah, that's quite interesting. Letter E is once again a totally different kind of problem too. So let's take a look at letter E. So I'd like you to, once I show you kind of one of each type, just kind of let you roll with it. But goodness gracious, these are totally different. So now this one's a little unique in a sense that we're trying to get that denominator to cancel out, but the top doesn't even have a common denominator. So the way it looks right now, it looks like nothing's going to cancel out. But maybe it will. We need to find out. So again, we could put this on the Desmos and we could kind of, that would be like almost cheating. But we will go ahead and what we want to do with the top numbers, you have 1 over x, and then you have minus 1/2. So what's the common denominator between x and 2?
X
What's
minus 2. X minus 2.
Well, you don't, the minus you can kind of ignore right now. That's just what you're doing to both of those expressions. But just between x and 2, what's the common denominator? The answer is 2x. Okay.
Oh.
So if 2x is the new denominator for both of them, okay, then the question becomes, what's the numerator? What's going to be on the top of that? It was 1 over x. If I make it 1 over 2x, well, what did I just donate? I donated 2 times x. So whatever I do the bottom, I got to do the top, right? So instead of 1 on the top, it's going to become 2. So it's 2 over 2x minus, and then what do I need to donate to the 2 that's on the bottom?
The x.
Exactly. Whatever I ever donate to the bottom, I got to donate to the top. So it's going to be minus x over 2x. So now this problem is getting quite interesting because it looks like nothing's the same when actually it's very much the same. So here's what I wanted to show. This is something they're putting a lot of things all in at once on you here. It's quite interesting. That's why I was trying to tell people it's the calculus it's not what gets people hung up. It's the you're supposed to have mastered all the other things up to calculus that get you hung up because they're throwing everything at once. All the things you learned in the algebra 1 and algebra 2 all at once. But anyways, you see where it says now the new thing is 2 over 2x minus x over 2x, right?
Mm-hmm.
And then this is all over x minus 2, right? The original denominator was x minus 2. So you see where I'm going with all that?
Yeah.
Okay, so you got 2 over 2x minus x over 2x, right? You follow that?
Mm-hmm.
Now what I'm going to do is going to be a little bit messy writing because this this Google writing pad's not the best. But I'm going to pull up this slide. It says I have no slides. Okay, hold on a second there, buddy. Okay, let me see here. I'm going to present. See if I can present this. Okay, here we go. Okay, come on. This Chromebook doesn't like doing this very well. All right, here we go. And all right, I called this. There we go. Let's see if you'll be able to see this. So I'll show you what I'm talking about. All right, so if I go like this, let's see, I'm right here. So I go. See if I'm right. Let me see if I can pull this pad down some. Let's see. So here we go. So we got 2. Come on, you got it right. Let me go back to this. Lets me do this. So far, it's not letting me. Let's say 2. Huh, maybe it's not going to let me. Let's try this again. Okay. All right. So we have, what did I just say? I said 2. Maybe I didn't like my hand on there. I don't know. 2. No, it's not going to let me do it, I don't think. Let me try to do it by hand. Let's see, 2. Still not going to let me do it. That's unfortunate. All right, so let me go back here. Stop sharing that. And go back here to StreamYard. Okay, so anyways, I'm just going to have to say it verbally somehow. But so what we have is we have 2 minus x on the top, all over 2x. You follow that?
Mm-hmm.
And then all of that, all over x minus 2. You have all that? Okay, tell you what. Let me do it like this. I don't know if you can see this. I can hold this up. Maybe you can see it like that. Let's see.
Yeah.
Okay. That make sense?
Yeah.
Okay. So now we can go from that. Say baseball game on Friday. Okay. Anyways, forgot about that. So here's the thing. This is what's very, I mean, I don't know, how familiar you are with this next step. So everything so far looks a little crazy because it doesn't look like anything's going to cancel. But there's 2 more steps that are going to show you that it actually will cancel. So what I'm going to do is I'm going to put 2 minus x all over 2x times x minus 2. And that's going to be my next step. So I'm going to show you that. Look what I've made a little rectangle. Okay, maybe it'll get up here. Let me see. Come on. All right, I'll bring this down. Maybe that'll help. Okay, here we go.
Okay.
Come on. Covering it up. Okay, hold on. So you can't see that, can you?
No.
That's kind of weird. All right, let me see. Settings. Let me get this settings changed here. Let's go. Let's see. No background. Okay, so now you can see there, right?
Mm-hmm.
Okay, now, see what I just put up here? Wait a minute, where am I at? Put it right here.
Yeah.
Okay, so what I've done, see that what was being divided by, when you divide, you can go ahead and pull up the second division right up with the original or the other denominator. That's a little math trick you can do. Follow that?
Mm-hmm.
So if I said something like 2 divided by 3 divided by 3, that's the same thing as saying 2 divided by 9.
Mm-hmm.
Okay, so I can take that where we had that x minus 2 on the bottom, we can bring that up. You got all that?
Yeah.
Okay, so here's the thing. It looks like nothing's still going to cancel. But you notice it says 2 minus x on the top, and then it says x minus 2 on the bottom, right? You follow that? So if I were to
Yeah.
say, let's say I said this to you. If I said, what's 5 minus 2? You would say what?
3.
Right. So then what's 2 minus 5?
-3.
Exactly right. So in other words, if 2 minus x is one answer, and on the bottom I have x minus 2, the difference of them is just a what? In terms of the way I could deal with them, it's just a factor of what? What would I multiply them by in order for them to be the same?
-1.
Bam. So what you're going to do, you're going to put a negative sign out front of where you see 2 minus x. And then on the bottom, you're going to keep it the way it is. It's going to say what? It's going to say x minus 2. Actually, sorry. You see where it says 2 minus x,
Mm-hmm.
right? So when we put that negative sign, you're not going to have 2 minus x anymore. Guess what you're going to have?
X over x minus 2.
Exactly right. Okay, and I'm going to put a box for that too. I put that underneath right here where my finger is. Okay. So that little minus sign allows for us to switch up the x and the 2.
Mm-hmm.
Okay. And now we can see something's going to cancel. What's going to cancel?
X minus 2.
Exactly right. So once we cancel that out, voila, it's going to be negative. Well, when we cancel it, it's still going to be left at 1 there, right? So it's going to be -1 all over 2x. Okay.
Mm-hmm.
And then you're going to, now you can go ahead and substitute that number in they said in the first place, which is what was that number?
2.
Okay. So it's going to be -1 over 2 times 2.
Well, -1 over 4.
Right. Now, if you had a calculator, right, you could, if you had a calculator, then you could type, like I was saying, instead. So for all these problems, you would type in 2 numbers, which is if they say as x approaches 2, you would type in 1.99, and then you would also do what's the other one? 2.001. And then what you would do is see if you get the same answer. If you got 2 different answers, then you would be saying, so if you got 2 different answers, then it would say, then the answer would be does not exist. If you got the same answer, then that answer, let's say the answer ended up being let's say if I substitute 2.01, my answer is 6.9999. And if I put 1.999, I still got 6.999. What do you think that limit would be? If they both ended up giving me the same number, which was 6.999, what's the limit? What's it going to end up getting infinitely close to without ever getting there?
Oh, 7?
Exactly. So the limit would be 7.
Hmm.
Okay.
Okay.
So limits are very similar to asymptotes. So an asymptote, you never get to something. A limit, you either get infinitely close to it, or you might actually get to it. It's kind of like saying, like if we say the greater than or equal to sign. So the when you get to an asymptote, it never has an equal sign. When you get to a limit, it's got the equal sign also. So it could be equal. Asymptotes can never be equal.
Okay.
Follow that? So if I
Yeah.
said, what's the speed limit? That speed limit means if the speed limit's 70, well, you have the written rules, right? This written rule says I can get to 70, but I can't go past 70. Actually, some freeways will say you have to go a minimum of 45. Okay, so minimum of 45 and a maximum of 70. That means I can get to 70. Now, the unwritten rule is if you're on the freeway, most of the time the highway patrolman is going to give you up to 10 miles past that. So if the speed limit is 70, they might give you up to 80. Just depends on the state you live in. Of course, Ohio's probably got the most strict. You'll see people, you can drive all over the country, and the one state you see people, slowing down in is Ohio. It seems to me Ohio seems to have the most patrolled highways in the country, and so you get the least amount of leeway. Not that I'm complaining; it's probably good for safety, but anyway. So that's the gist of that problem there. Now let's see if there's any other ones that you think might give you a headache. Let's see if there's any other type of problem. Okay, so that F is a different problem. F is a value. Theta, theta just means an angle. So if you put I don't see how that's gonna 0 minus, or theta is 0 approaches, so it's 0 minus 1. That's not going to be 0, so that's okay. So that's just putting the values in. Okay, but what's any E is actually a number, right? E is the number is like 2.71, and it keeps on going just like pi does. It's an irrational number, goes on forever. It's called the natural base. So if I put 0 in for, see, it says 2 theta. So 2 times 0 is 0, right? So any number to the 0 power except 0. You can't take 0 to the 0. But any other number to the 0 power gives you 1. So e to the 2 times 0, e to the 0 is 1. And 1 minus 1 is 0. And so 0 divided by 0 minus 1, 0 divided by negative 1 is just 0. So what's the limit for letter F? It's 0. Yeah. Of course, you got to show your work on that. In that case, you can just substitute the number in, and you don't have to worry about doing any kind of removable discontinuity or anything. So that's actually the easiest problem on there. All right, let's see what else might give you some headaches. Okay, so letter G looks like is really a stupid problem. But if you just are given a limit, so that what limit 2 is just a number. So numbers can't change. So it doesn't matter. You could put as, what does that say? R? I can't even read it.
R
approaches 7, I think it says. Okay, R could go to 1 million, 1 zillion. It doesn't matter. 1 trillion, it wouldn't matter. The answer is still going to be 2. So that's because that's a straight line. That's the equation y equals 2. So no matter where you're at for the x value, it's still going to be 2. Okay. And so yeah. So let us. That's quite interesting too. Let's take a look, and this goes some other things too. All right, so number 2 is totally different too. But let's take a look at letter I. Let me check something too while we're doing that. Make sure this thing is, first off, we got a text down here. Let's see. Home Depot, your order is running late. Just great. Now they're talking about Wednesday. Tanya? Gotta let my dad know about that one. Jeez, they're backing me up. Is what they're doing. But anyways, let's see here. Which means I really got to wait till a day later than that. Okay, hold on a second. Let's see here. Your videos live. Huh. That's weird. Okay, but anyways, that's supposed to be streaming right now on live, but I don't see it on there. But maybe it is, maybe it's not. Anyway, so we'll figure it out. One problem is it didn't run on time, or I set it for 3 and it started after 3, so that might have hurt it, but it'll live. Okay, so anyway, so let's take a look at this one here. So as x approaches 0, okay, again, anything to the 0 power is going to be 1, except 0. But it says x, okay. But then on the bottom you have x times e to the 0. Well, that would still be 0 on the bottom. So we got to figure out a way if we can get an x on that top. And I'm just looking up there. All right. Okay, do you know anything about cosine and sine? Well, first off, cosine of 0 is 1, but the sine of 0 is actually 0. So it'd be almost like saying 0 divided by 0. And here's the problem. You ever heard of there's some rules for cosine and sine. I'm sure they must have given you some kind of identity sheet with cosine and sine with trig values. I'm pretty sure they won't make you memorize that. Did they give you? Yeah, I'm pretty sure they gave you something, because when you start doing 3x, when you start doing that, like cosine of 3x and sine of 5x, there's some different angle identities that can help you make substitutions. And then there's some other stuff that I don't know if you can use for that, but there's definitely going to be some type of identity. Do you see anything with cosine of 3x, or cosine of any cosine or sine identities? Yeah, I don't see anything on here. Let's see here. Nothing on there. Okay. They give you any notes on anything? I don't see anything on there. Well, anyways, let me see about if I can pull up some things here on that note. Let me see here. Let's see, trig, angle. Hmm. I don't see any good ones. Let me see here. Okay, yeah, there's something right here. Let me see if I can pull that up. Taking so long to load, it ain't funny. I'm going to go back to you because it's taking, well, wait a minute, maybe it started loading. Let me see. Still loading. Did you find anything on your end? I'm going to take my phone off the internet. Maybe that'll help. Okay. Anyways, I try to load up some trig identity stuff. Okay. It says lessons. I don't want lessons. I just want to see it. Identity sheet. All right. I see one right there. Let me see. Video. Mm, okay, there you go. So, all right. Sine of 2 theta is 2 sine cosine sine. Let me see. So let me go over there. Back to that. Let's see. It doesn't say 2. It says 5. Sine. You still there, Dalen? Dalen, you there? Let me make sure I didn't turn something off. Can you hear me now? You hear me? Can you hear? Yeah, I can see your lips moving, but I don't hear anything. So he's got his mic off. You got to
I can hear me now.
unmute mic. Yeah, I can hear you now. Yeah, I couldn't hear you for a little bit there. Call it an angle identity. I mean, what do you call it? Trig identity. And so because we need to get that. Okay, what happened here? Okay. All right, so I see you there. You there, Dalen?
Yeah, can you hear me?
Let me see something here. Yeah, I can hear you.
Oh,
I don't know if I'm cutting out or you are, but kind of going in and out. Let me see here. What I was looking for is a um, is a trick. Got to get something to cancel. I'm seeing double angle, so I'm just looking for. They call them cheat sheets, but like trig identity cheat sheets.
hmm
Um, they should have given you something. They can't expect you to do that off the top of your head. So unless they're just wanting you to plug in numbers, like I said, like use a calculator, plug in like instead of zero, type in 0.001 and see what it looks like. That kind of working it out, getting exact answers. It's without unless they're going to give you some, some an identity work, sheet or tell you what to memorize, which is doubtful at Columbus State that they're going to make you do that, or any other school for that matter, except maybe some High State might do something silly like that. But let's see if I can pull this up. Okay. Some of these tabs, maybe that'll help the computer a little bit here. Anyways, if you could, maybe you can do it on your side. You can pull up a trig angle identity cheat sheet. See if you can Google that, and then we'll share that. See if you can share that screen. Because for me, it's starting to work a little faster, but it's let me see if I can get to pull up first, then I'll share the screen that I have.
Okay.
Originally, this was going to be a YouTube thing. I don't know if it's going to be on there or not, but we'll find out. I tried to pull it up, I didn't see it, so doesn't mean it's not on there. I might wait till it's. I should have done it live, but anyways, we'll see. Live. Anyway, so now let's see. I don't know if you found something. I'm looking on here. Okay, I see. Oh, let's see. Theta plus no. Okay, I see a bunch of double angle stuff. I don't see what I'm looking for. I don't see any with that kind of deal in there. Not on this sheet here. Some double angle stuff and. You find anything on your side over there?
Oh, no.
Nothing over there. All right, let me try one more sheet before I give up. I'm trying to find that. I can tell you what they want to happen. They want an X to cancel out. So there's going to be a way that you can rewrite the top so that an X is going to cancel out on the top and the bottom. And okay, so let me see if this one. Let's see if this one's helpful. Okay, here we go. The tangent. Let's see. Okay, it says I'm looking for. Yeah. Trig functions. Yeah, I didn't see anything on there, and this takes too long to pull up. But let me see if I can pull it on my phone. Maybe that'll be helpful. Let's see, trig angle. Okay, let's see what we can do here. Let's see. Paul's online notes. Hey, I like that. See, Paul's got some good stuff. We'll see if I can get this. All right, let's see if I can find something here. I use Paul's notes a lot. Let me see if it's going to get it to us, though. Okay, summon product. Yeah, okay, so it says anyways, I didn't see. All right, we'll have to. I'm gonna try to get back to that. Maybe get you. Maybe take a picture of it and send it to you when I find a nice trig identity sheet. Because even Paul's notes is. I don't see what I'm looking for, and I may be kind of wasting time trying to, because they may not be asking you to do that anyway. But anyways, I don't see one right off the top, and usually they're pretty self-explanatory. So let me go back. All right, so we'll go back to that one. That one, I want to write that one down. That one was 2 cosine of 3x sine of 5x all over x e to the 3x as x approaches 0. Okay. So that's that. All right. So now let's see if we can't pick another one of these bad boys. I saw one, number 2. It was talking about give a definition of use a limit definition of a derivative of a continuous function. It says, what does it say again? It says give the limit definition of a continuous function.
Mm-hmm.
Yeah, so they should have given you that in your notes, but it should be limit as x approaches, or you could say h approaches 0. As h approaches 0, it should be x plus h, or f of x plus h minus f of x all over h is one way to define it. But you can look that up and see which one there's different ways to write that, but that's, so it should be limit as h approaches 0 of f of parentheses x plus h minus f of x all over h. Okay, they did use the terms that I've been talking to you about. The very next question, it says, for each of the following, find all the values of x for which the function is something. I can't read the rest of that, but you see what that says there? It says each of the find all the values which the function is not continuous. Classify it as each as discontinuity, as either removable, asymptotic, or jump. Now that's interesting. Jump. I haven't even talked about that with you. So there's jump discontinuity. It means that, literally the graph jumps. I guess that's kind of what it does. Okay. Yeah, it says limit each of the following functions. Find all values for x, which a function is what? Is not continuous. So what can you never divide by?
0.
Right. So what you got to do is, do the same thing we were doing on the top. Just figure out what you can get removable. I mean, if you get something removable, and if it's removable, you just say that it's If it's removable, you say it has discontinuity at the two places that you factored. Right. Okay. Why don't you go ahead and do the first one? See where it says x squared plus 6x plus 8. X squared plus 6x plus 8 all over what? X squared plus 2x minus 8. So what's the factors on the bottom going to be?
X minus 4.
Yep. No, x, and I say
Plus
plus
4.
2. Yeah. So x plus 4, and then what? X minus 2.
Yeah.
Okay, what about on the top?
X minus 2.
Everything's plus on the top, so guess what?
Plus.
What's that?
So just plus. X plus 4. X plus 2.
Say that again. I apologize.
X plus 4. X plus 2.
Okay, x plus 4. Yeah, exactly. And then what's going to cancel?
X plus 4.
Okay. Okay, so what are you left with?
X plus 2. X minus 2.
Right. Okay, so then what does it say? It doesn't say. So what you say now? See, what we did was we were able to remove the x plus 4, right?
Mm-hmm.
So what you would say? So you got two things you're going to say. Number one, you're going to say that because it doesn't tell you what anything's approaching. So what you're going to say is that 2, since we weren't able to get rid of, see where it says x minus 2, what would make that 0?
The 4.
No, what's on the bottom still?
Oh, 2.
Yeah, so 2 minus 2 is going to be 0, right? So you would say f of 2 is what?
Not continuous.
Remember, it's the V word. It's the vertical asymptote.
Vertical asymptote.
Yep. Anytime you can't divide by something, it's got a vertical asymptote. Unless we removed it. So at f of 2, you would say f of 2 equals vertical asymptote, right? Or you could say D and E, the limit doesn't exist, whatever you want to say. And then, and what else? What's the other one? F of negative 4, what are you going to say that is? Removable?
Removable discontent.
There you go. So now, so what would you classify the function as, though? I mean, if you're saying this is all one function, you would have to say it's what?
Asymptotic.
Yeah. Yep. Yeah, you would have to say that. Now, as far as the one that's jump, right? Yeah, is there going to be one of these that's jump? Well, look at letter B. Letter B says it's a line. When x is less than negative 2, it's a line. When x is in between negative 2 and 1, it's a parabola. And when x is bigger than 1, it's a line that starts up at 5 instead of, see where the first line starts at -3? You know how you have y equals mx plus b? So that one, and you can put this on Desmos. You can just Google Desmos. Yeah, what's this? This is called a, what's this called? Piecewise function. If you Google Desmos piecewise function, you can put this in there. And anyway, so this one here, let me see if you can pull that up on here. If I can go to Desmos, if I can look up piecewise without Googling, let me see if I can find piecewise. Probably not. So what I'm going to do is I'm going to Google Desmos piecewise graphing. Okay, function graphing. Okay, I'm just going to put graphing. I'm going to leave. Let's see what happens. Okay, we'll see how it does it. Well, let me see. Find out. I'm going to put it on your screen. Know if I can manipulate this or not. You can have to read me this equation you got, but let me see. All right, so it's getting ready to show you this. This isn't yours. When x is what, less than something?
Yeah. -2.
What's it say? When x is less than what? -2?
Yeah.
Okay. And what does it say the equation is?
X.
What's it say the equation is?
-3.
2x minus 3?
Yeah.
Okay, hold on a second. So I'm going to get rid of this other stuff here. Okay. 2x minus 3. Let's see if that worked. I should see a graph that looks like 2x minus 3, and right now I don't. When x is less than 2, 2x minus 3. Okay, 2x minus 3 should be 2x minus 3 should be, well, let's take a look. I don't see the graph right now. It should be on there. 2x minus 3 is just a line. So I said when x is less than -2, it should be 2x minus 3. Well, -3 is down here. I don't see that graph. It didn't cooperate, I guess. Let me see. Um, 2x minus 3. Huh, that's, anyways, it's not cooperating, but it's unfortunate because that's pretty, it would be pretty nice. Anyway, so that's, anyway, you should be able to do a piecewise function on there, but let's just, let me entertain it real quick. I'll try to graph it by hand, I guess. Let's see here.
This is simple. I could get to class.
I'm not sure why. Okay, buddy. I'll anyways, if you ever want to get back on there, we'll get back on. But I don't know if that video will show up or not. But anyways, the piecewise functions, that's probably where you're going to get your. Oh, you did? It did show up?
Mhm.
Okay. All right. Well, I guess I'll get back with you another time.
No, thank you.
You're welcome. Hopefully it helps you a little bit.